a technology even Einstein feared. Quantum computers have become reality. Imagine this. You wake up one morning and see this headline on the world news. Quantum computers are bringing an end to the classical world. But this journey didn't start overnight. It all began at the dawn of the 20th century, when scientists were trying to unravel the mysteries of the atom. Back then, physicists saw the universe as running like a perfect clockwork. With Newton's laws, they believed every movement and all energy could be predicted in advance. But in 1900, when Max Planck discovered that energy is emitted in packets, this classical understanding was shaken. And soon after, Albert Einstein took the stage. In 1905, he proved with the photoelectric effect that light could behave both as a wave and as a particle. Einstein's breakthrough earned him the Nobel Prize, but also opened the door to a world he himself would one day call spooky. In the 1920s, the work of Bohr, Heisenberg, and Schrödinger laid the foundations of quantum physics. Heisenberg's uncertainty principle showed that the position and speed of an electron can't be known with absolute certainty at the same time. Schrödinger's cat made us imagine a system that could be both alive and dead inside a box. Einstein, however, kept questioning the randomness of quantum mechanics, famously saying, "God does not play dice." Yet quantum physics began to break the boundaries of the classical world, one by one. Electrons could be in two places at once, atoms could be linked through entanglement, and information seemed to travel faster than the speed of light. And most intriguingly, these oddities wouldn't just remain in the subatomic world. They would soon take center stage in computer technology. In the 1980s, Richard Feynman and David Deutsch argued that classical computers fell short when it came to simulating nature's complex systems. The solution? A computer that harnesses quantum physics. In 1994, Peter Shor stunned the world with an algorithm showing that quantum computers could crack classical encryption in seconds. What was once impossible was now possible in the world of quantum possibilities. So, why are quantum computers so powerful? Because classical computers store information as either 0 or 1. In quantum computers, the basic unit is the qubit. Thanks to superposition, qubits can be both 0 and 1 at the same time. Entanglement means the two qubits are linked by an invisible bond. If the state of one changes, the other responds instantly. This allows millions of possibilities to be calculated all at once. Today, companies like IBM, Google, D-Wave, Rigetti, and IonQ are pouring billions into quantum computers. In 2019, Google announced that its quantum computer, Sycamore, solved a problem in 200 seconds that would have taken a classical supercomputer 10,000 years. This milestone, quantum supremacy, made headlines worldwide. Quantum computers are now being tested everywhere, from portfolio management to drug discovery, from traffic optimization to weather forecasting. J.P. Morgan is using quantum computing in finance, Roche in healthcare, and Volkswagen in transportation. We may not have quantum computers in every home yet, but thanks to cloud services, they are already becoming daily tools for scientists and companies. Quantum computers are no longer just a theoretical curiosity or a toy for scientists in labs. The world's leading tech companies and governments are spending billions without hesitation to win this race. A new kind of technological Cold War is unfolding between the U.S. and China. Tech giants like Google, IBM, Microsoft, Amazon, Baidu, Alibaba, and Huawei unveil faster and more stable quantum prototypes each year, increasing their qubit counts. What's behind all these investments? Humanity is dreaming of boosting computational power by thousands of times to discover new drugs for complex diseases like cancer, run real-time global weather and climate simulations, manage risks in international finance within seconds, optimize supply chains to eliminate energy and food waste. But just as quantum promises to be a superhero, it also has a dangerous side. A quantum computer could easily break all the encryption systems that keep today's banking and internet secure. That's why cybersecurity experts are racing to test a new generation of encryption methods called post-quantum cryptography. Meanwhile, governments are in a race to build unhackable networks with quantum communication. In the 2020s, China's Mishi satellite successfully transmitted the first messages encrypted with quantum keys. The fusion of artificial intelligence and quantum could pave the way for truly intelligent machines as once only dreamed. Quantum computers can process massive datasets far faster than classical computers, giving AI a new kind of brain. Medicine, energy, automation, logistics, agriculture. There's hardly any field left untouched by quantum dot. It's not just technology society. Itself is preparing for the quantum revolution. Universities around the world are launching quantum education. High schools are adding new courses in quantum coding. Young people are now writing algorithms not in classical computer labs, but on quantum circuits. Startups, investors, and major funds are entering the quantum space with big hope and boldness. Quantum has also taken over art and pop culture. Movies like Interstellar and Tenet have introduced quantum concepts to millions. On Netflix, series like Dark and Devs dramatize the weirdness of quantum and its effects on people. Young scientists on YouTube explain quantum in a way everyone can understand, while quantum memes go viral on social media. In the midst of all these developments, the biggest unknown still remains. When quantum computers become truly widespread, what will change in our lives? How will concepts like privacy, ethics, and social justice be shaped? And how much control will humans have over this revolution they themselves created? So the real question is the quantum revolution just about technology, or is it the start of a new era that will fundamentally change the way humanity understands itself, the universe, and reality? Today, every one of us watching this video is a witness to a turning point in history, to a massive transformation. The technology Einstein once feared is now one of humanity's greatest hopes. And we're standing right on the threshold of the quantum revolution. In the end, it's not technology itself, but the people who use and guide it, who will shape the future world. If you want to join us on this journey, witness how quantum will affect our lives, and never miss the latest tech developments. Hit subscribe, leave a like, and share your thoughts in the comments. Because in the quantum age, knowledge is power, and power comes from learning together. See you in the next video.